Good morning, good afternoon, or good evening, depending upon where you live around the world. Where we left off was where I had prattled on a little bit about scaling of the different models, and how that if you've got to be careful when you're scaling that you don't scale everything that you have on your screen, or more critically, you may well scale things if you're using layers that will or will not scale. And often you want to scale everything for whatever reason, but oftentimes there'll be parts of your model that you would prefer not to. So that's what I touched on, whereas I find that when and that's where you have to have all your layers exposed, because there may be locked items hidden for whatever reason, but you need to have them all exposed if you want to scale it all or in part. And as I mentioned, what I do is I cut them, rather than copying them. I cut the items I don't want to scale the bits that I do, and then I paste back into place those that have been unscaled. Hope you follow that and watch the previous video. I have also made 2 more videos subsequent to the number 2, and I have deleted them. As I said, I don't really edit them a great deal, but if they're egregious to my ego, you kind of never see them. There's a few mistakes that I make, like I could refer to these as hexagons instead of pentagons, and etc. I also touch on a particular building method that I use. The principle behind that, or the meaning, or the reason behind that, is I wanted to emphasize the process. And if you don't have a correct process, sometimes we'll make unforeseen or troublesome errors. And the process itself is what allows you to double check yourself, oftentimes. So off to the right there, you may have seen just poking itself into the corner of the screen, I've got this dome, or the base upon a form of a dome. It is also viable and inaccurate geometrically. Trip over those words, because while it is accurate, all the pieces joined together and they're not gapping, etc., there's a few shortcomings. As you note, this was, we haven't got to it yet, I've deleted that video, but this was based upon, and if I just draw in a different screen, there we go, is based upon this, the pentagon based sphere. So you're only using pentagons. There's no hexagons in this particular version. And that dome that you saw, which we'll go back to in a moment, that dome was based on this combination of the pentagons. You can also see, quickly back here, this is a more, air quotes, normal type of dome that we would think of, a 2V dome, where the pentagon is facing upward. That's normal. As you see here, and this is a little hint for where we're going, you see effectively a pentagon facing upward. However, pentagon facing down. How does that come about? Well, it was based upon one of that drawing where I showed you the pentagons only, and of course the side ones face down, and I've generated this type of dome from that structure. That is why when I say geometrically correct, while that is correct, it may be not sphere correct, or it's got its own minor issues. Viable, Yes, usable. Yes, valid. Pretty much, but it may not be the ideal one that we use. I like this because you only have to make 5 of these, or actually 6, because you've got 5 around the side and the top pentagon. And the only fudging which you will have to do is when you create this triangle, of which you make 10 of these triangles, one for each side, of course, times the 5. And if you can draw in your fudge and determine the lengths and the angles, etc., it's a more than reasonable thing to do. Standardizing, so this one triangle here is 30. You make 30 of them. Sounds a lot, but we know what domes are like. They've got lots of triangles and faces. But 5 for here, 25 for the sides, plus another 5 for the top. But it's one triangle 30 times. Tick. That's a good. And then 10 of these, once you've determined them, and you can make yourself a dome. Fantastic. Not a bad thing. So how did we get to this point? Well, that's where we come back to our pentagon here, and we're going to orientate ourselves or create the, now where are we, this version from it. And it's relatively straightforward, but there's a few little issues, and we want to go through those issues so that you can choose. I'm only showing what I've fallen across, some of which I use, some which I don't. Long-winded. So we'll go back to this, and how do we create it? Now, I can't recall in the previous video whether I mentioned that it's wise to rotate this to the same orientation as this. That's not critical, but it's wise, and it's the amount that you have to rotate it was important, and which points need to be anyway. If I inserted this, if I know that it's 5 meters away, but if I moved it back 5 meters, it disappears completely into that structure. I have rotated it correctly. As I said, I just can't recall whether in the previous video I mentioned that or not. And these lines we mentioned are the radii. Again, I can't recall whether I mentioned, but I cover it again. These lines that we drew in ignorance, simply following Paul Robinson's method, I didn't realize that they were the radii of this structure. Knowing that now, I can make use of it. We may or may not in this video, but we shall see. If you lose, say you delete the lines, and it could be a little bit tricky to get the geometry just right, well, you can go back to this. That's why I pop them off to the side, and then if I have to, I can use them as a fallback. Now, what I want to do is to create the radii. Let's just see whether, as we've got here, we've got one line coming down from the top, one line coming from, which is the peak of the pentagon, and we've got another line coming out to this peak of this pentagon. This is telling me that that is the center of the dome, the radii. The radii, in my definition, is the maximum length from the center of the dome to any point on the dome, the peaks of the pentagons. But when I want to use it in a slightly different manner, which we're going to get to, I know that that's the length I want to use. I also know that that length is approximately 1396, bottom right hand corner. And as a measurement with the about or approximate designation against it, I know that's not pleasing to me. I could, and I'm not going to, but I could resize this so this is a full, how would you say, like 1 meter or 2 meters. It's a round number. And I'll touch on why that's beneficial and why at the moment I'm leaving it out, because I'm just showing you what you have to do to get this radii to pop out through the center of this triangle. Now, what is the center of the triangle, or where is the center of the triangle? I find it easiest to go from the apex to the middle of this line, this edge, and put a guide in, or a line, but I guide in. I have found, this is a SketchUp thing, it's sometimes glitchy when I go from the edge to the, hang on, I don't want to do that. I find it sometimes, I don't want to do that, because it's referencing the line, whereas if I'm, and that's not the reason I made that comment, if I do that, I create the guide that I want. But I have found sometimes it won't stick, and I don't know why that is. Not knowing why, I keep away from it. Now, another guide from the center, well, that, by the way, has found the dead center of that triangle. So I now go from the center of the radii out there, and I put another guide. I know that along that line somewhere I can draw that same length here. I'll get rid of those two guides for clarity's sake. So there is our the line of the radii. Now I need to get that line, which I will explode. I need to get that line to poke out there, and doing so isn't as straightforward as you would like. Anyway, I digress. It's easy to rotate that through the horizontal plane and go to the center of that edge, that line. I know I'm central along that axis. Now I need to rotate that up to here, and the easiest way, again for me, there's 3 or 4 different ways. I know that that line, that alignment is the correct alignment for the rotation, and I've popped it down here. Now I'm going to rotate the line by going there and hitting the guideline. That has orientated my radii of the correct length, because it's just one of these ones rotated. I've rotated it into its correct position. I didn't copy it before, so I'll pop another one in there. So that's 3 of the radii for this next step. Get rid of the guides. I can unhide things. Now, oops, just want to grab that. What I do there is rotate through the horizontal plane. I'll come around to here. I know that it's 72, however I type it in out of habit. Why? Because I've clicked, I now no longer can do it. I'd have to then copy and rotate it again, which is a pain in the neck. So I can undo that, select my line, come up here, reference it, turn it, copy it, type in 72 times 4. That allows me to do that. That's one reason for doing it. The other thing is, good habit, I like typing in exact or accurate numbers, mostly. You can rotate by snapping it to the different points, equally fine. I, however, have found in different situations it better to type it in. And as I say, it's out of habit. Again, coming back to process, I'm a person of process, I can assure you. I'll do this. This has created 5 points at which we can draw a line, and the last one creates the pentagon. It also is underneath is the scaffold. If I just hide some of this, which is a little bit confusing here, but it's a scaffold upon which you can draw that pentagon, and is effectively that upside down pentagon based pyramid that I talked about in a previous video. In one of the videos I deleted, I actually showed it and I rotated around with the sides filled in, but not this one. Scaffold, center of the dome, very center of the whole structure. Okay, now, oops, oh, actually I might hide that one. I can rotate this. Now, which angle do I want to rotate it round? That was part of my comment from the very first video, was that sometimes I prefer doing it in a more agricultural method. A straightforward, no frills, no sophistication, gets the job done, complete, I'm happy. But it's more satisfying sometimes as you move along the learning process to use the rotate facility, but which line is that to be rotated around? And that's when I say sometimes I get lost and I just do it the simple way. But let's just try this one. So if I rotate that round, got lucky, 72 degrees. Interesting, because if you rotate it around you choose a different point of rotation, it might have to be 120 degrees. I know that for a fact. This case I chose correctly, but I'm going to type in 72. Could I do that again around here and rotate it? Yes, I could. Or I'll simply do it the simple way of rotating it around 72 degrees times 4. And bingo. There we have the structure upon which we will carry on this investigation. I'll just get rid of some of these bits that I don't want just now. We may pop them back in a moment. But there we've got the base upon which we can create our dome. But before we do, I'm going to be nice to myself and group that together. And I will hide that. Have I grouped everything there? No, that's not grouped. It's not necessary. I'm not worried about that. And hide. So now I'm going, actually I might just do a little aside. It's something I thought about previously. Hide. Come through here, hide everything there. Right, I'm just going to do agricultural method. I'm going to move. Actually, no, I will rotate and copy. Oops. Well, that was very clunky. (180 degrees). I can then, nothing fancy about this, I can take that straight down and stick it there, rotate it round slightly, and then I've got my complete, air quotes again, dome. Pentagon only dome. Looks good. Everything lines up. I could do the explode and then see whether all the faces are sticky. I know this is correct, but if I was doing, this is just the exercise, but if I was doing it for something that was going to be more critical and I wanted to build from later on, I'd probably explode it and use that test method that Paul Robinson made me aware of. Delete that. Don't want that. Now, what's this doing out here? That we know is a radii line. That. If I draw a guide, well, that's interesting. That, of course, not to you. You're probably already ahead of me. That creates that, or is the same point as there. Interesting. If I now join them together, I better colour it for our sake, otherwise the colours tend to blend in with each other. Bring this in. What colour are we going to do? We'll make it that colour. Bit of a spearminty colour. Now, if I rotate that, and I'm going to use that little radii, the line there, if I use that as my, and if I reference, if you're doing some complex shapes or multiple shapes, and especially when they get a little bit smaller, hover your rotation tool around there, hit the shift key, it will lock it in, so wherever I go it's going to retain that same relationship. And now I'll release the shift key, I can rotate this round, oh gosh, 72 degrees times 4, and I have my upside down pentagon, which is this one here. As we created this shape, pentagon only shape, where all the pentagons were identical and placed around the other edges of the top pentagon, that means all of these points are flat. They are level, which is a good thing. When you're building something, you want to have ideally something sitting on the ground, or a foundation, a slab, that's all of the same level. And oftentimes it's not the case when you're creating domes. Just saying. Now, I want to rotate this around, and I'm just going to put a guide up there. Oops, that's not the one. Okay, so I've deleted the vertical guide, radii. So what I need to do now is to take my guideline, put it in there, and it gives me my center line that around which I can rotate 72 degrees the pentagon times 4. That gives me the walls, we could say, or the sides of the dome. Yay. I can then take this and rotate it round. I can't really show you it there easily. Let's just take that and nope, can't do it that way. Can't do it easily. Let's take it from, and this is, I'm making a point here, let's take it around this one. Oh yes, I can do it. Oh, look at that, 120 degrees, which was that 120 degrees I was talking about earlier. They are precise and accurate measurements or degrees, and therefore geometrically accurate. But note that I had some trouble choosing which line of radii, and in fact it was this one here. And when you start to do this sort of stuff, it plays with the brain and you start to perhaps lose context and choose the wrong one. But it's SketchUp, you can redraw it. That's why sometimes I just simply draw the triangle up here, rotate it around. I do what's simple, and that's why I keep on referring to the agricultural method, not to denigrate anyone working in that field. That's where my family came from, was the agricultural industry, but many years ago. But it's something that is more referencing the wisdom and understanding of I want to get a result, I want it now, and you get it done, like you often do on a farm. Anyway, I digress once more. I want to now, what do I want to show you now? That was kind of like the hard way. Kind of. Now, I'm going to move this across. I'm going to scale it up a little bit. Just to prove or emphasize the point. The time is running on this particular video. We have got a very pleasing dome. Except we have to infill these triangles, and this is where I was saying geometrically accurate or whatever, but there's a glitch that's required to get this infill panel, because if I do this, join them up like that, yeah, actually I don't know whether that's pleasing or not. I kind of feel, I said in the previous video, the one which I deleted, that that's not pleasing. I actually wonder whether that is actually quite pleasing. And because it's triangulated that area, simply, you only need to make this one triangle 5 times. You've got to make this triangle 30 times. You know, that's just what domes are like. You have to have lots of triangles to make a dome. But there is only one, in this case, the walls and the roof, only one triangle. That's a big plus, it really is. And this is one triangle 5 times. I have over here shown it more, air quotes, correct, but it's a fudge of a fudge. I wanted it to be effectively plumb, be straight up and down, or at the distance out from the center of the dome to make it more correct. But that is the radii, and it's buried underground if you wanted to do it semi-correctly. This one, I actually do wonder whether that's actually a good and aesthetically pleasing way of completing this particular dome. After all, domes are, for the general populace, odd or different. That's why I did it mine, my first one, when I was still in my teens, back in the 70s, and I'm now wondering whether that's actually a good idea. Might have to think about that. I quite like this one because of its simplicity. You make, as I said, you make 30 of these triangles, yeah, but you only have to make 6 of these pentagons. So as a set, you can make them together. Take the 5 triangles, make the pentagon. That's a rigid, self-supporting structure. Fix it to each other to make the base, and then pop the top on, which is the same as that. That's actually, really talking about it, that's actually quite appealing. I think I might have to make one of these. Might make a small one and see what I think. Anyway, I've digressed. We actually, if we wanted to do this correctly, we need to take the radii length and pop it out here, which we've done here. You wind up with, and I will draw it, a semi-correct surface. I'm going to hide that. And that's, oops, I've just hidden the wrong one. Actually, I'll tell you what, I'll delete that, and I'll delete that, and I'll do it again. So that would be the semi-pleasing, geometrically correct triangle. It's kind of not, but it fulfills my requirements. But to have it sitting flat on the ground, I've got to truncate it, which I can do by making it. And this is the beauty of SketchUp. I can go through iterations. So that would be then swapped or rotated around to the side, and you would infill this section, and that would be more dome-like and pleasing for the surface. Probably the better way of doing it. It does give you a direct line of energy and force down to the ground. The other one, not so much. If you were to use this point to try and fix down the dome, the pressures have to be dissipated out to these, along these struts, to these points. So could be a good idea. Don't know. This one probably is better. So anyway, I just would rotate that round. There's something interfering there. I'm going to rotate that round the horizontal to there. Glitchy. Because, oh, sorry for that. That just told me that that line is not perpendicular, not plumb. That is why we got that. Interesting. Okay, delete, rotate round. Damn. Rotate round. Going from there. Oops. Rotate round. Let's put a guide in. Let's rotate round that, shall we? Pause. Yep. Now that process told me that as I was mentioning, this also isn't, well, you can see it probably there. Very hard to see sometimes when you're drawing. So I'm going to take a plumb line. It's only that much out, which on this size dome is not a huge dome, but it's 11 millimeters or so. Not much. And you probably wind up fudging it anyway. But there is your completed dome. Rotate those round 5 times, etc. And it's flat on the base. Is it worth it? Don't know. I'm actually putting that in the possibility drawer. It's worth investigating. That's not where we're going, and we need to touch on the one easy way of doing this, in fact the radii, and then we'll go on from there. That is way longer video than I've made in the past. I kind of apologise for that, but not. We will go straight into the slightly easier version in the very next video. Okay, that's it. See you later. Bye now.